Okay, my dear students, today we discuss the main topic, that is transportation problem. Okay, transportation problem is a special kind of LP problem in which goods are transported from a set of sources to a set of destinations subject to the supply and demand of the sources and destination respectively, such that the total cost of the transportation is minimized. That is very important. It is also sometimes called as Hitchcock problem. So, what are the types of transportation problems? So, here this is a matrix model. That one first. So here balanced and unbalanced types of transportations are there. So what is balanced? So when both total supplies and total demands are equal, then the problem is said to be a balanced transportation problem. Next, unbalanced. When the supply and demand are not equal, then that is called unbalanced transportation problem. So, now we discuss the balanced transportation problem. In this type of problem, either a dummy row or a dummy column is added according to the requirement to make it a balanced problem, to convert a balanced. Unbalanced also can also to be converted into balanced model. Then it can be solved similar to the balanced one. Okay, next. There are two phases to solve the transportation problem. In the first phase, we find the initial basic feasible solution. Initial base IBFS has to be found, and the second phase involves optimal basic feasible solution that was obtained that was obtained from the first phase. Okay. Phase 1, that is finding the IBFS. Phase 2 is optimization of that initial basic feasible solution. That method is MODI method or UV method. So, first to solve the IBFS, there are three methods are there. So first one, northwest corner cell method. Second one, least cost cell method. Third one, Vogel's approximation method. VAM. So that one. Or penalty method. Okay. So what is the transportation problem in mathematical model? So here this is the matrix model. Here sources are O1, O2, O3 and O4 are the sources, and that are the sources, and destinations D1, D2, D3 and D4 are the destination points. Next, the matrix model, the cells are cost values, that are C11, C12, C13, C14, like that one. Last one, that is C41, C42, C43 and C44. Next column, that is supply units, S1, S2, S3, S4, and demand, that is availability, and this is the capacity. Demand, that is the D1, D2, D3 and D4. In the above table, D1, D2, D3 and D4 are the destinations where the product or goods are to be delivered from different sources, S1, S2, S3 and S4. S1 is the SI is the supply from the source OJ. SI OJ. Okay, next. DJ is the demand of the destination DJ. CIJ is the cost value when the product is delivered from source SI to destination DJ. That one. Next. So what is the method? What the first one method, that is northwest corner method. So how to solve a given transportation problem by using northwest corner method? An introduction to transportation problem has been discussed in the previous section in this article. Finding the IBFS by using northwest corner cell method will be discussed through a problem that is very easy. So first here source values O1, O2, O3 and destination points D1, D2, D3 and D4. Here cost values, here 3 rows are there and 4 columns are there. So M is 3 and N is 4. Next supply units are there, 300 in the first row, 400 in the second row, next third row, in the third row 500, that are the units. Next demand units are in the first column 250, second column 350, third column 400 and last column D4 200. So here the total supply units is equal to 1200 and total demand units also 1200. So the given transportation problem is balanced one. So now we go to solve. So how to solve that one? First explanation. Here the sources are O1, O2 and O3. For the destinations, that one. For the sources O1, O2 and O3, the supply units are 300, 400 and 500 respectively. The destination values D1, D2, D3 and D4 have demand units 250, 350, 400 and 200 respectively. Next, now starting from the northwest corner method, now to start from the northwest corner cell, that is O1D1. O1D1, the method also same, that one top left one, that is O1D1 has to be the starting point, that is the northwest corner of the table. Each and every value in the cell is considered as the cost per transportation. Compare the demand for column D1 and supply from the source O1 and allocate the minimum of 2 to the cell O1D1 as shown in the figure. The demand for column D1 is completed. So the entire column D1 will be cancelled. The supply from the source O1 remains 300, minimum value of 250 and 300, that is 250. Okay, 250 units can be allotted to O1D1. So the remaining 50 units are there in that row 300. Okay, that one. Next one. So that column is over. So because D1 column is completed or satisfied. Next, okay, in this the 50 units are there in the first row. Next, now we move to the cell, that is O1D2. So here 50 units are there and 350 units are there. So minimum value is 50 units. So allot this O1D2 cell 50 with 50 units of the supply value. So that 50 units O1D2 allocate the minimum among the supply for the respective column and the rows. The supply from 1 to 50, which is less than the demand for the D2, that is 350. So allocate 50 minimum value to the cell O1D2 since the supply from the row O1 is completed. Cancel the row O1. The demand for column D2 remains 350 minus 50, that is 50 units. So now complete this first row also completed. Next, now we go to we go to the cell that is O2 D2. O2 D2. So first column also is over and first row also over. The minimum among the supply from the source O2 that is 400 and demand for column D2 that is 300. So allocate 300 to the cell O2 D2. The demand for the column D2 is completed. So cancel the column and the remaining supply from the source O2 is 400 minus 300. The remaining one is 100. So 100 is there in this second row. Okay. A second column is satisfied or completed. So that value is 0. Now we move to the cell O2 D3. Now we can move the cell O2 D3. Remain the table O2 D3, northwest corner that is O2 D3, and compare the O2 supply that is 100 and the demand for the D2 that is 400 and allocate the least value that is 100 to the cell O2 D2. The supply from O2 is completed, so cancel that row. The remaining demand for column D3 remains 400 minus 100, that is 300. So now cross over the second row, that is O2 line. So 400 100, that value is 0. Next now we can move the cell that is O3 O3 D3 proceeding in the same way. We final values of the cells will be this table, that are the remaining units can be allotted to the last row, that is O3 D3 cell and the remaining O3 D4 cell. So totally completed. So compare that one. The total supply and demand values are satisfied, that is 0 0 0 0. Here also 0 0 and this one 0. So completed by northwest corner method. So that is finally we can find the total transportation cost with minimum by northwest corner method, that is 250 into 3. So that values are 250 into 3 plus 50 into 1 plus 300 into 6 plus 100 into 5 plus 300 into 3 plus 200 into 2, that is this calculation. So that total value is 4,400 rupees. This is the minimum transportation cost to the given transportation problem by northwest corner method. Okay, that one. Now we go to the next method, that is least cost cell method or matrix minima method. The northwest corner method has been discussed in the previous one. In this article, the least cost cell method will be discussed to the same problem. So here also same that one problem. So total supply is 1200 units and total demand units also 1200. So this is a balanced transportation problem. The given transportation problem is a balanced one. So solution according to the least cost cell method, the least cost value we can choose among all these cells in the table has to be found, which is 1, that is O1 D2, that is O1 D2. So allocate maximum units to this cell O1 D2, that are 350 that are 350 and 300. Compared to this two, 300 is the minimum value. 300 is the minimum value. So allocate 300 units to this O1D2 cell, because O1D2 has the least cost, that is 1 rupee. So allocate 300 units to that cell. Okay, that one. That is this table. So in the first row, 300 units can be allotted to that O1D2 cell. So first row satisfied. So cancel that one or mark that one as a line, crossed line. Okay, that is over. Next, now we go to, so in that column, D2 column, 300 units are over, the remaining are 50 units. Okay, 50 units. So next step, okay, next step. Now find the cell with least cost among the remaining cells. So observe that from the table, next least values are in the O2 D1 is 2 rupees, and also last one O3 D4 in the third row, O3 D4 cell also same, that 2 rupees. But which one we can select, that is O2 D1, because O2 D2 can be allocated to maximum units, that is 250, and O3 D4 cell maximum allocated are 200 units. So which one is more, that is O2 D1. So allocate 250 units to O2 D1 cell. So O2 D1 cell can be allocated to 250 units. So here the 250 units are there, and demand in the supply to 400 minus 250, the remaining are 150. So here satisfied column, first column is satisfied because 0 units are there. So first column, that is D1 satisfied. So first row over and first column over. Next we go to that cell, that is O3 D4 cell. So this also minimum cost rupees, that is 2 rupees. So allocate the maximum units, that is 200 units. So 200 units can be allocated. 500 minus 200, that is 300 units. So here 0 units are there. So D4 column can be cancelled or satisfied. So cross out that line. Next, so 300 units are there in that third row. Next least cost cell value, that is 3 rupees in the O3, in O3 D2 and O3 D3 also. So which one we can be selected, that is which one we can selected, that is 3. మిస్టేక్ చేశాడు సార్, అక్కడ దీనికే ఇవ్వాలి, అందుకని మిస్టేక్ చేశాడు, అట్లా చెప్పేసి. So that is O3 D2 cell, that is 50 units can be allocated to that cell. Next, so 350 minus 50, okay, that is 50 units. Next, in the O3 row, third row, so third row, that is 300 minus 50, remaining are the 250 units. So allocated to that one, అందుకని మనకి ఇక్కడ రో తప్పు చేశాడు, అందుకని ఆడుతున్నాను. Okay, next one, the remaining cost rupees, least cost value is again O3 D3 cell. So next, allocated to that 250 units can be allocated to that O3 D3. So here 0 units are there. Here 400 minus 250, remaining are 150 units are there. So here O3 line, cross out the O3 third row O3. third row O3 because satisfied, that line satisfied. Next, least cost cell value, that is 5 rupees cell, 5 rupees cell. So allocated to 4 rupees, 4 rupees చేయకూడదు సార్, ఇది అయిపోయింది, అయిపోయింది. Okay, 5 rupees cell, that is, so the remaining in the D3 remaining units are 150. Here also 10, so 150 units can be allocated to that cell. Okay, that one. Next, cross out that 0 is there, cross out that D3 row, D3 column. So all units are completed, all units are completed. So 0, 0, 0, here also 0, 0, 0, 0. Okay, all units are completed. So now we can find the IBFS, total transportation minimum cost by this least cost method. So 300 into 1 plus 250 into 2 plus 150 into 5 plus 250 into 3 plus 200 into 2. That is this calculation. That total value is 2400 rupees. That is the minimum cost of the given transportation problem by least cost cell method. Least cost cell method. Next, we go to the third method, that is the Vogel's approximation method. This is also very important method, and this is the very predominant method compared to the remaining methods. So how to solve by Vogel's approximation method? This is also known as penalty method. So now this is same problem. So this is also a balanced type. Total supply is equal to total demand. So this is also a balanced one. So for each row, how to solve this problem? For each row, find the least value and then the second least value and take the absolute difference, that is the penalty of these two values, and write the corresponding row difference as shown in the image below. In the row O1, 1 is the least value and 3, next least value is 3. Okay, next difference, that is least to first least one 1, second least one 3. So difference is 2. That is the first row penalty value, that is 2. In the second row, so first least value is 2, second least value 5. So difference 3. 5 minus 2, 3, that is the penalty. In the third row, first least value 2, second least value 3, either any one, 3. So the difference, that is 1, that is the penalty. So row penalties are there, or row differences. Next, column differences. So in the first column, least value 2, next least value 3, difference is 1. In the second column, D2, so 1 is the first least value, second least value 3, difference is 2. In the third column, least value is 3, next least value 5, difference is 2. In the fourth column, again 2. So least value 2 and next one 4, difference is 2. So this is the first round of the penalties, row penalties and column penalties. Okay. Okay, that is the first stage. Next, now in these penalties, either row or column, highest penalty value is 3. So choose that row, least cost value is 2 rupees. So allocate the units to that O2D1 cell, that are 250 here and here also 250 is the least value, minimum value, so allocated 250 units to that O2 D1 cell. Okay, here the 250 is over, the remaining is 0. Here 400 minus 250, the remaining are 150. So the first column satisfied because 0 is there. Now go to next step, again write the penalties. So in this in the now first column is over. Now we find the penalties to the remaining values, the remaining table. Okay, so in the first row least value 1, next least value 4, 4 minus 1 difference is 3. In the second row 6 and 5 difference 1. In the third row 3 2 difference 1. In the first column no first column, so leave it that one. Next in the second column 3 1, that is difference 2. In the second column, third column, in the third column difference 5 minus 3, that is 2. In the fourth column the difference 4 and 2, that is 2. Okay, now choose the highest penalty, that is in the row differences first row has the highest penalty, so choose that row. Least cost cell, that is O1 D2. So allocated have maximum units, that are here 300, here 350. So 300 units can be allocated to that cell. Here the remaining units 0. Here 350 minus 300, the remaining are 50 units. So this first row is completed, so cross out that one. Now we go to next round, that is now we find this one is over, this row is over. So next write the penalties again. So in this second row 6 and 5 difference 1, 3 and 2 difference 1. Next in this first column no first column completed. Next in the second column 6 and 3 difference 3. Next D3 column 5 and 3 difference 2. 9 next 4, this is over. 9 and 2 difference is 7. That are the penalty values. So in this stage the highest penalty is 7. So choose the column D4 column, choose the column D4. So least cost value is 2 rupees. So allocate maximum units to that cell, that are 200 and 300. Maximum can be allocated is 200, the remaining is 0. Here 500 minus 200, the remaining 300. So here D4 column satisfied, so cross out that column. The remaining units already we can choose very easily, or we can write by penalty method. Okay, in the first row over. Next difference 6 in the second row 6 5, that is 1. 3 3 is third row 3 3 difference 2 0. Next in the second column difference 3 6 and 3. In the third column 5 3 2. Okay, that one. So here highest penalty is that is only 3 units. 3 units is the highest penalty. So next allocate that column maximum units, that is 50 units. So 50 units, that one, that is over. All units are completed. So 0 0 0. Here also 0. Allocate this 150 units to this cell and 250 units to this O3 D3 cell. So that is next table. So that is completed. So now finally we can calculate the total transportation cost with minimum by Vogel's approximation method, that are the cost values 300 into 1 plus 300 into 1 plus 250 into 2 plus 150 into 5 plus 550 into 3 plus 250 into 3 plus 200 into 2. That calculation is this one, that is rupees 2850 rupees. That is the solution of the given problem by this Vogel's method. So that one. Next, now we discuss in this transportation we discuss the concept that is unbalanced. How it will be, we can choose unbalanced. So if the total supply and the total demand both are different, the given problem is definitely unbalanced transportation problem. Example, here this is the sources and these are the destinations. Here the supply units and here the demand units. So total supply units 117, 117 and total demand units are 95. So both are different or not equal. Total supply is not equal to total demand. So here total supply is more than total demand. That is important one. Total supply is more than total demand. So in the supply column we can insert a dummy column. We can insert a dummy column in the supply column. So that is dummy column D5. Next one, that is the dummy column with zero cost values 0, 0, 0, 0 and the corresponding rim value, that is units. How many units are there? Here 117 in the old supply column supply values and demand 95 units are there. So difference is 22 units. That can be the rim value. That can be the rim value 22 units. Now this is a balanced transportation problem. Now this can be used by any method of the above three methods. That by the above three methods, any one. Okay, that one. రన్ అవుతుంది